So here's a question with the logistic equation. And I wrote here in green basically what the logistic equation was. Here is basically the solution. Okay, the solution to the logistic equation. Here is what A was. And if you remember correctly what the logistic equation was in differential equation form. So we started off with this thing. Okay, and then we solved this in the previous video, so if you want to take a look at that, you can see it. And then here was our solution. So here's a solution to the differential equation, and this was basically what the value of A was. So based on this information, we want to do this problem. So here, if you want to take some time to take a picture of this or write it down, please do. So we have a population growth according to the given logistic equation. So we have actually numbers plugged into the differential equation, and we have an initial condition right here. So where t is measured in weeks. Okay, so here what we want to find is what is the carrying capacity and also what is the value of k. All right, so if we kind of trying to look and eyeball this, let's write down the differential equation. So dp over dt is equal to k times p 1 minus p over m. So remember here that you're just basically trying to figure out what the carrying capacity is and what is the value of k. Well, the value of k is always going to be the number right in front of the p. So in this case, it's going to be 0.04. Okay, so k is equal to 0.04. Okay, so you can think of this as a growth rate. Okay, so that's the value of k. What is the carrying capacity? The carrying capacity is just the value of m. In this case, m is in the denominator inside the parentheses, which is this guy. So m is equal to 1,200. Okay, and that will be the answer for that one. Okay. Part B, write the solution of the equation. So the solution to that equation, if you see over here, is right up here. So we know that P of t is equal to m over 1 plus a e to the negative kt. Okay, so here our m value is just going to be 1,200. Okay, 1 plus a, okay, I'm going to write a by itself for right now, e to the negative k, which is 0.04 t. Now, what is a going to be equal to? Well, a is equal to m minus the initial population divided by the initial population. Okay, so m in this case is 1,200 minus the initial population. Do we know the initial population? Yes, we do. It's given to us as a IVP. So this initial condition says that at time equals 0, the initial population was 60. So I'm going to have 1,200 minus 60 divided by 60, which is going to give me 19. So I'm going to plug that in there. So it's going to be equal to, let me write this out in a different color, 1,200 divided by 1 plus 19 e to the negative 0.04 t. Okay, and that is going to be the solution to this differential equation. So when you have problems like this, you don't need to do this problem over and over and over and over again. Okay, the reason why I did it once is that we don't have to do it again. So now all that you know what the solution looks like, given any problem that has a logistic equation, you don't necessarily have to do the integration, separation of variables, partial fractions over again. We already know what the solution should be. Okay, so we just plug them in. Okay. All right, so part C says, what is going to be the population after 10 weeks? All we have to do is just plug it in. Since I know that P of t is equal to this guy, so all I got to do is plug in 10. So this is going to give me 1,200 divided by 1 plus 19 e to the negative 0.04 times 10. Okay, so I'm going to put this into my calculator, and I'm going to get about 87.4 weeks. Or 87.4 of the population. People, individuals, I don't know what this is. Okay. All right. And now this is going to be part D. Part D says, after how many weeks will the population reach? About 1,000. So round to the nearest week. Okay. So now in this case, this is going to require a little bit more work. So we are given that P of t is equal to 1,200 divided by 1 plus 19 e to the negative 0.04 t. And what we want to figure out is what exactly is the value of t, because that's the weeks, when the population is about 1,000. Okay, so what we're going to put is we're going to put 1,000 here, because that's what the population is, and we're going to solve for t. And this is going to require a lot of messy algebra, okay? And you have to be very comfortable with this, okay? And if not, just go ahead and just, there's a ton of YouTube videos on how to solve exponential equations of this kind. So the first thing that I'm going to do, I'm going to multiply the denominator to the other side. So what I'm going to have is 1,000, 1 plus 19 e to the negative 0.04 times t is equal to 1,200, okay? Now I'm going to divide by 1,000. Okay, so what I'm going to have is 1 plus 19 e to the negative 0.04 t is equal to 1.2. Okay, now the whole point of solving this exponential equation is that you want to be able to solve for this exponential part. So let's get rid of everything else that's in the way. So for example, this 1 is in the way. Okay, so what I'm left with is just 19 e to the negative 0.04 t is equal to 0.2. Let me go ahead and divide by 19. So I'm going to have e to the negative 0.04 t is equal to, let's just leave it as 0.2 divided by 19 to save some digits. Okay, now I need to get rid of that e, so I'm going to take the ln to both sides. Take natural log, and I'm going to have negative 0.04 t is equal to the natural log of 0.2 divided by 19. And then finally, we're just going to divide by this negative 0.04. So t is equal to the natural log of 0.2 over 19 divided by negative 0.04. I put this in my calculator, and we want it rounded to the nearest week, and I got 114 weeks. So in about 114 weeks, we are going to have a population of about 1,000 based on this logistic equation, okay? So with these problems, notice that there really is no calculus that you have to do. The calculus have already been done for you. But what you really have to do is be able to piece everything together by figuring out the logistic equation, okay? The solution based on what they give us, the value of A, and then be able to do a couple problems using just some algebra that you've learned from pre-calculus. So if you still feel a little bit lost with the algebra, please make sure that you review the exponentials with logs. This is just some of the algebra that you've learned there, but just practice it. It's somewhere in your brain. You just got to practice it. So in the next video, we're going to do one more logistic equation that's a little bit more involved, and you have to do a little more algebra before you get to the other problems.